So in an effort to put together all these observations, again, water's boiling point being so high, much higher than is available in our atmosphere, yet it's so passive up there in the atmosphere when it's in the droplet form. And lastly, then under certain conditions where its surface is maximized, it has the ability to form this really thick plasma. And I came across the notion of hydrogen bonding. Hydrogen bonding simply says that the water molecule's shape dictates that this oxygen molecule here sucks down more of the electrons, making this more negative and making these two little Mickey Mouse ears here more relatively positive. And that creates this kind of a hydrogen bond going on here. But that didn't really answer any of my questions. So I wondered if there might be something more going on with hydrogen bonding than just that. And this is what I came up with. I wondered if hydrogen bonds themselves might in some way have something to do with neutralizing the polarity that's in that's in water molecules. And the logic works out as such. Here is a water molecule that has 2 hydrogen bonds on it, and that is the liquid form of water, and that would explain why when water is in a liquid form in the atmosphere, a droplet let's say, it's relatively passive. It has no more polarity because that polarity has been neutralized by these 2 hydrogen bonds. And this would be a steam molecule, and of course this would be one that wouldn't really exist in our atmosphere. But because its polarity is so high when there's nothing attached to it, that explains why the boiling point is so high. And then this one right here is what I imagine the surface tension would look like. In other words, this had one molecule attached to it, but it still had some degree of polarity. Note that these numbers in here indicate the polarity. In other words, this had half the polarity of the steam, but since it had some polarity, this was a hard connection. And so that explained how water has this surface tension and the ability to form hard bonds and some degree of electromagnetic activity that I would associate with some kind of a plasma. So I'm referring to this as their polarity coefficients, and I'm saying that polarity coefficient is variable and it gets neutralized when bonds are complete. It's fully activated only when bonds aren't complete at all, and it's in half polarity coefficient. It's in half polarity when there's only one associated with it, and this allows the pieces of the puzzle to come together to explain what's going on with water in the atmosphere. It allows us to understand why there's that high boiling point and why there's no steam in our atmosphere. It also explains why those molecules don't come together because they're pacified once they go into little droplets. And if those droplets can somehow be elongated, they become hard, and that explains not only how they are electromagnetically more active to effectuate kind of a plasma effect, but also it explains how those little threads of polymer, water, stay intact and don't just go flying off, because as that little polymer elongates, it activates the polarity and activates a hard charge between them.